Today we are going to be talking about adding and subtracting polynomials. Adding and subtracting. This pen is not going to work, so I'm going to grab a different pen. Maybe. That pen is not going to work.
Do you need a pen?
Nope, I'm good. Thank you, though. I appreciate that. That's a kind offer. So adding and subtracting polynomials. Polynomials. So I got it so it's sharper now. So crisp. So sharp.
What was wrong with it?
I had for some reason the resolution got set to super low. So when I zoomed in, it looked really bad. But now I set the resolution so it's higher. So there is some delay now, but it's fine. Kind of the best of both worlds. All right, so this prefix poly, you guys have seen before. Do you guys remember what the prefix poly means?
Nope.
Okay, so you have seen it with shapes, like polygons and polyhedrons.
Polyester.
Polyester, yeah, okay. You probably have seen it in like Miss Barella's class too, though, like polytheism. Like the Greeks were a polytheistic culture.
Multiple gods.
Yeah, so poly means many. So polytheistic, in that case, when the Greeks were a polytheistic culture, it means they worshipped multiple gods. Poly means many. Polynomials,
So many numbers.
yeah, many terms in this case. So we're going to go from having just plain x to having many different types of x's. We're going to have x and x squared, and x cubed, and x to the fourth. We're going to have many different types of x's in one thing now.
Dude, how many x's in one place?
That's limited only by your imagination.
Oh, I know.
So, okay. So an example of something that's a polynomial here. Let's say that we have something like, let's do 2x plus 4x to the fifth minus 7x squared plus 8x minus 2. All right. Okay. Now, there's no equal to, so this isn't an equation. All right? There's no equal to. This isn't an equation. We're not solving for x because there's no equal to anywhere. We're not doing equals 5, so you wouldn't have to solve for x. Okay? What we do have to do here is we have to look for any like terms, any similar x's, and see if we can combine them. Now, x's will only combine through addition and subtraction if they're the same type of variable, meaning they're the same x or same y, and if they have the same exponent. So here, I've got a plain x, I've got x to the fifth, x to the second, another plain x, and then I've got something with no x's. So the only ones that will combine through addition and subtraction are 2x and plus 8x. These two will combine through addition and subtraction. They will not combine with 4x to the fifth, and they will not combine with minus 7x squared. Okay? So one way that you can think of it is like this plain x and 4x to the fifth, it's like they go to the same school, but one of them's a senior and the other one's a 7th grader. They might go to the same school, but they're not going to be in the same English class. Okay? So just because they're in the same school, they're both x's, doesn't mean they're going to be in the same class together because they're like one's a plain x and the other one's an x to the fifth. Same thing with x and x squared. Maybe one's a 7th grader and one's an 8th grader. They're not going to be in the same English class. Does that make any sense? So you can't combine them through addition and subtraction. But these two, the 2x and the 8x, you can combine through addition and subtraction. Because they're both x, and they're like, not one of them is x squared, like they're both just plain x. Okay? So 2x and plus 8x, how many x's does that make? So this is going to be 10x. And then everything else just kind of drops down because I couldn't combine anything else with it. So plus 4x to the fifth minus 7x squared and then minus 2. Nothing else could combine. I can't combine this with that because while they're both x's, this one is plain x and this is x to the fifth. I can't combine these two together. This is x to the fifth and this is x squared. And I can't combine this with that because this one doesn't have an x. Does that make any sense? Now you can multiply these things together and that's just fine. All bets are off if it's multiplication. But if it's addition or subtraction, you can only add or subtract if they're the same variable and the same exponent. All right? Now, one thing about math that's one of those weird things is that in math, it's considered proper for you to have the variable that has the highest exponent come first in any order thing. So when we're looking at these, which of these variables has the highest exponent? So 10x, 4x to the fifth, minus 7x squared. This one has the highest exponent?
No. I said 4x to the fifth.
Yeah, 4x to the fifth has the highest exponent, right?
No.
Yeah, it does. It super does. So this one should come first. It's considered proper in math to have this one be the one that comes first. So it's just rude. It's like the mathematical equivalence of rude to have this one come before that one. So we should rearrange these so that 4x to the fifth is first. And then what should come second is the one with the next highest exponent. Right, and so the next highest exponent isn't just 7x squared, it's minus 7x squared. We got to keep that sign with it. So it's negative 7x squared, or minus 7x squared. And then the next highest power of x is the plane x. Now there's no sign in front of this 10x.
So it's just plus.
Yeah, so it's just plus 10x. And then the last is going to be the one with no x's at all, which is minus 2. And so this is considered the proper way of writing that. Despite the fact that there's no difference between the two mathematically, this one is considered less rude than that one. It's just how math is. There's a lot of weird little quirks about how mathematicians like to see their stuff written out, and this one is considered better than that one. Okay, so let's talk some more about what we're doing today. So this is the key idea behind what we're doing today, is that we're adding things that have the same variable with the same power. Now, how that's going to look some more on today's assignment. If I have something that's in a set of parentheses here, let's say I have 2m squared plus 5m, close parentheses, and I'm going to add that to another set of parentheses here that's going to look like, let's say 8m squared plus 6m. All right. So when I'm adding these together, I want to make sure that I'm only adding together things that have the same variable to the same exponent. All right? So to do that, I'm going to do 2m squared. I'm going to add to it anything over here in this second set of parentheses that has the same variable to the same exponent. So 2m squared plus anything in this second set of parentheses that is the same variable to the same exponent. So what can I add to that? Okay, so 2m squared can be added to what from over here? 8m squared, right? And that's going to make how many m squareds? So this is 10m squared. All right, cool. And then 5m squared plus 6m squared makes how many m? Or sorry.
Yeah, it's not m squared.
Sorry. Thank you. You're absolutely right. I was wrong.
That was off.
5m plus 6m makes how many m's? So this is going to make 11m. And it doesn't change the m to be m squared. It just stays plain m. I misspoke. I apologize. And so then this would be your final answer. You're just combining things. These two cannot combine any further because one's an m squared and the other one's a plain m. You guys with me?
Oh, that's not too hard.
Okay. So let me have you guys try one of these on your own. I'll come check. And then there's just one more step up from that we're doing today.
Oh, God.
All right, so let's try one of these on your own. Let's do 3x to the fourth plus 7 in one set, plus x to the fourth plus 8. So try doing that on your own. Copy that into your notes. Give it a try. And I'll come around and check. Raise your hand if you don't understand it, and I'll help you. Raise your hand if you think you got it, and I'll come and check.
Wait, what do we do with that?
Perfect.
We add them?
You don't add the exponents when you're adding. You just add the numbers in front. Perfect. So this is a 1x. Yep, and there's perfect. Perfect.
It doesn't. It don't.
Great. Yeah, come on. Even Colton did it. Cool. If Colton can do it, you can do it. That's going to be my new catchphrase. If Colton can do it, you can do it. No offense, Colton.
Yep.
Good. If Colton can do it, you can do it. Plus. There you go. Colton can do it, you can do it.
But then what if I don't do it?
Yeah, but you did do this.
But what if I didn't?
I would make you do it. Do you need a pencil? Great. Do you need paper too? You sure? Okay, good. Good. All right. So, let's take a look at a tiny bit higher than this, all right? Just like a notch higher. But I totally believe in you guys. You can super do this. Okay. So, first of all, before I go any further, I just want to throw some terminology at you guys. So, in math, things with two terms. So I use the term polynomial to refer to things that have many terms. If there's specifically two terms, like there was up here, so this thing with two terms is called a binomial. Bi meaning two. I'm going to throw something out that has three terms. And if it has three terms, any guesses what that would be called? Yeah, trinomial. So let's do 3 minus x plus 7x cubed, close parentheses, minus, parentheses, 6x cubed minus 7 minus x squared, close parentheses. All right, we're going to do this one together here. All right? Don't freak out. We're all going to be okay. All right. So we're going to do one thing at a time and combine everything together. And if anything doesn't match with the other thing in the parentheses, we just drop it down. All right? So here's how I go through one thing at a time. And I underline everything as I go. So I'm going to start with the 3. So 3 minus negative 7. So that minus negative is going to make it plus positive. So this is 3 minus negative 7, which is really 3 what? 3 plus 7, which makes 10. So I'm just going to drop down to 10. All right, cool. And I've dealt with the 3 and I've dealt with the negative 7. And I'm underlining both of them to show that I dealt with both of them. Okay, next I'm going to do minus x, minus, and then there's no plain x's over here. Do you guys see that? So I'm just going to drop down minus x because there was no plain x's for it to match up to. Okay? Now I've got plus 7x cubed. I'm going to underline it. And I'm going to do minus 6x cubed. So 7x cubed minus 6x cubed is how many x cubes? Yeah, so it's 1x cubed, right? Because 7 minus 6 is 1. So I'm just going to say 1x cubed. And should that be plus 1x cubed or minus 1x cubed? Okay, so plus 1x cubed. Now, what is not underlined so far? So the minus x squared, but it's minus negative x squared. So should I write it down as minus x squared or plus? Yeah. So it's plus x squared. Do you guys see that? All right. Now, personally, if you guys got this far on a quiz, I would be overjoyed if you had gotten all of these signs correct. However, I am required by law to teach you that mathematically this is considered rude. So mathematically, the true correct answer is to rearrange this so that the x cubed goes in front, So 1x to the third, and then the x squared goes next, plus x squared. The minus x goes next, minus x, and then the plus 10 goes last. This is considered more correct than that, despite the fact that they're both the same mathematically. What are you doing with the scissors, dude? Just stop. You're gonna hurt yourself. Yep. Yep.
They just interrupt our class.
Okay. So, let's take a look at the assignment for today. We're going to go through the first four together, like we usually do.
Yeah.
As usual, we're going to go through the first four together. And then I will
What's up? What's up?
Stop that. We're going to go through together. If you knew how to do it, I wouldn't need what taught me to you.
I don't know.
How is this gonna help us?
Okay. So, this is the building blocks for quite a few complicated math things that engineers have to do on a daily basis and a lot of other math careers. Hold on. Let me finish. Next, second of all. So like I could list off a bunch of different like ways in which this math connects to day-to-day life. The next way that this would help you in your day-to-day life. This is something complicated with a set of instructions that I'm giving you that I expect you to follow through with a minimal set of oversight from your boss. That's every job ever. So yeah, this connects quite a bit to what you would be expected to do on a day-to-day basis in your life. Your boss is going to give you a set of instructions, something complicated to do, and then expect you to do it without being like having your hand held all the way through.
I'll just quit. My own boss.
Okay, or you can be your own boss, sure. All right,
Yeah, I have my own company.
let's go back to okay, number one. Number one.
Called
5n to the fourth, okay, fine. 5n to the fourth plus negative 2n to the fourth. Tanner. 5n to the fourth plus negative 2n to the fourth. What does that mean? Super not. There we go. Colton. 8n plus 2n. Should I add 10n or subtract 10n? Great. Number one is done. Boom. All right, Mason. The king of doing the first four problems. 5m squared plus 2m squared. How many m squared? No. Squared. When you add, the exponent doesn't change. Mason. That's very, the exponent only changes when you multiply. When you add, the exponent doesn't change. Okay? All right. Mason still. 2m to the third plus n to the third makes how many m to the third? And should I add 3n to the third or subtract it? Great. Mason, bonus round. What is the mathematically not rude version of the correct answer? Okay. Janine.
3m, and then
3m to the third.
and then plus 7 after the
Great. All right. Lucas. Okay. I've got 2x to the third minus negative 8x to the third. So minus negative 8 is really what? Right. So 10 what? Perfect. Okay. Lucas, still you. X squared minus 2x squared. Close. There we go. Perfect. All right. Malik. Negative 8x to the fourth minus, and then there's no x to the fourth. Great. Brennan. I have this minus minus negative x hanging out with nothing to subtract it from. What do I write down? I have minus negative x and nothing. So plus x or minus x? Okay. Bonus round. Who can tell me, raise your hand if you can, the non-mathematically rude way to answer this question? All right, Lucas.
Negative 8x to the fourth plus an x to the third minus 1x to the second.
Wait, what was the last part?
Minus x. Hold on a second.
Negative.
Because it's plus x, because it's minus negative x. Who corrected him on the plus x part?
Me? I did.
Oh, was it you?
Yeah.
It was not you.
What are you talking about? I have a very feminine, soft voice at times.
We do that.
Okay, then it should be me that gets that answer then.
You would just sell it.
I would.
Probably. All right. So let's say we do the next one.
In that case, I got the next one.
Okay. So let's see, Destiny. So I got 6r, and then minus negative 6r makes how many r's? No, minus negative makes plus positive. 12r. So I got 12r. Okay, cool. Destiny still used. I've got plus 5, and then no regular numbers to match it up to. So what do I do with that? Plus 5. Okay, cool. Mr. Persoma. I've got plus 7r squared minus negative 2r squared. So minus negative makes plus positive. So I've got 7r squared minus negative 2r squared. Huge question. Okay, so minus negative makes plus positive, right? So 7r squared minus negative 2r squared. Other way. 9r squared. And should that be plus 9r squared or minus 9r squared? Great. Perfect. All right. And that deals with this. And then back to you. I have this 8r to the fourth that wasn't used at all. What should I do with it? Minus 8r to the fourth. Okay. So Brendan and Lucas are out of the running. Bonus round. Raise your hand if you can tell me the mathematically not rude way to write this. Okay. Cameron, give it a try.
Negative 8r, 9r, 12r, plus 5r.
Okay. Missing a few things in there.
Hi.
Okay. So I wrote down what you wrote, what you told me. Hold on. Let's give Cameron the transcript. So you told me negative 8r, 9r, 12r, plus 5r.
R to the fourth.
Okay, so negative 8r to the fourth.
Squared.
Wait, sorry, say that again. Negative 8r to the fourth.
Plus
Uh-huh.
9r squared.
Great.
Plus 12r.
Great. And then just plus 5?
Yes.
Okay. Cool. I'm with you, dude. Cameron, sometimes I think you're on a different wavelength than the rest of us, and that's not bad. There's nothing wrong with being on a different wavelength. What? No, there's not. Our country was founded upon people who are on different wavelengths.
No, our country was founded on rebels.
Right, different wavelengths. All right, cool. So you guys can work in your plans for the rest of this. So, no, I'm the meanie. Yep. Are you sure you didn't look at the rest of the assignment? You'll need it for the rest of it.
Where were you with? Yeah, I thought you
This
were.
was fast. Double A, no. I have triple A. Bye.
Right. You're right. Nice. I had to reinstall it. Now I was hoping to God I never